Well, welcome to the session. My name's Pete Griffin. I'm the tech lead of the Google Landing team. I'm working on Pixel upstreaming. And
I'm not working. So I'm Krzysztof Kozlowski, and I work in Linaro.
So this is the agenda for the session. Krzysztof's going to do a kind of overview of Samsung SoC in the kernel, and also the SoC upstream status of SoCs that have landed since last Connect, and also an overview of what's on the list, so what will be coming up soon, and then look at some of the gaps and missing features, and then the presentation's in kind of two halves. Then I'm going to look at GS101 and Pixel 6 specific status. I'll talk to my bits, and then other people, Andre and Tudor and the team, are going to talk to the stuff that they've landed upstream. And then finally, we'll go with some of the CI and stuff that's happened, help we may need from people in the audience. Okay, take it away, Krzysztof.
Thanks. So, short story about the Samsung in Upstream Linux Kernel. This will be very short. I will skip very old SoC designs like S3C and S5P. Only Exynos here. Dates are approximate. So in the upstream, it started around 2011 with Samsung forks, upstreaming the first ARMv7 processors. More interesting here part is around 2013 and 2014 when the Samsung engineers, actually Samsung assignees to Linaro, they upstreamed the Exynos 5420. So this is the first Samsung octa-core design. And this is cool stuff because this SoC was also released on the market similar time. So they brought up the upstream support closely with the market release. In 2014-15, there was an upstream of first ARM64, Exynos 7. So these were cool times. However, unfortunately, in 2015, the Samsung LSI, which was the company, let's say, manufacturing, designing, responsible for Exynos, they backed off from the upstream. And the remaining engineers were not connected with the SoCs. So still, the engineers in Korea and Poland, they were able to upstream completely new SoC. It was Exynos 5433, also 64-bit. And they brought it over the years to the nearly complete support. However, this also faded out, and around 2017, 2018, it's pretty quiet. This was a very, very quiet time for me. I'm the Samsung SoC maintainer in the upstream kernel, and this was like a really, really cool time that I did not have my job. But in 2021, things restarted. So Linaro had a project. Sam Prochenko was doing Exynos 850. Also, Samsung activated themselves with the Tesla FSD, which is also Samsung SoC, Exynos Auto, and also community appeared with David was upstreaming 7885. So what's happening recently? So this is the status from since last Connect last year. We have pretty new Exynos, pretty new support for Exynos processors. I'm using here numbers for the marketing name. So the actual numbers, they wrapped. So this is why I also put here dates of release. And after Exynos 9810, there is a 990. So they just changed. Anyway, all of them have pretty basic support in the upstream. So this was brought recently. We have the pin controllers, clock controllers, maybe some serial buses, but these processors, these new supported processors, they lack a lot. And we'll later share a bit what's missing there. I'm also device tree device tree bindings maintainer, and obviously I'm interested in having the DBS check passing. So since few releases, Samsung has a warnings-free approach, since actually 6.3. And I'm pretty sure that I want to keep this status, so it's a strong intention that there should be no new warnings. And a standard, this is actually nothing new. So the same with other subsystems, that the Linux Next is decisive, so I will not take the DTS patch before the binding is being applied by the subsystem maintainer. So the subsystem maintainer should take the driver's binding, and I will take the DTS. And I actually tested and complain and send emails. I have a CI for that. So what's coming on the list? So the community is still working, and it's actually really cool news. I mean, I'm constantly surprised that there are some guys doing things for around the Samsung phones or other phones using Samsung processors, right? So we are having on the list 2 new SoCs, 7870 and 2200. Again, the numbers wrapped around, so I put the dates of the release of the SoC, approximate dates. So Kaustab, I probably mispronounced the name, is bringing pretty complete support for 7870, like with USB storage. This is really, really great job. And Ivalo is bringing the beginning of Exynos 22100. For the existing SoCs, there are also patches which are being reviewed and worked to bring USB and serial buses for one of the SoC. An interesting new bus, it's called Speedy. This is one wire, and a nice coincidence because I'm also maintainer of the one wire subsystem, but this is different one wire, and the Samsung Speedy bus is different interface. And Markus is trying to upstream the Speedy bus for the PMIX in the Samsung. So yeah, this is on the list. What we are missing? We're missing a lot. So I mentioned that one of the last efforts was Exynos 5433. So this was done, the release of the SoC was I think 2015 or something like that. Finish of the support was 2017. The teams upstreamed everything and it's nearly complete support. But since then, all these things did not progress. So all the new SoCs, they miss audio, they miss camera, they miss display, almost everything. More interesting, right? The only easy thing here is the GPU because the designs, the Exynos uses the ARM Mali GPU, and these devices have support in the upstream kernel. You just need to add the DTS. The problem will start with Exynos 22100, which uses the AMD GPU, and there is, I think, no upstream driver for that one. So, yeah. And here I really hope that Google Landing team will bring the missing pieces because this will be now their problem.
Okay, so the next part's about GS101 and Pixel 6 specific status. So since 6.8 was the first kernel where GS101 landed, and this is kind of an overview of what we've been working on recently and what's landed. So just recently, some pin control enhancements went upstream to select analog or digital filters on the pins. So this was some technical debt that upstream driver didn't have and newer Exynos-based SoCs use. And also, we fixed some bugs on suspend resume for handling these register offsets. So with that, the upstream driver is kind of feature complete with the downstream driver. And our kind of overall goal is to replace the downstream drivers with the upstream drivers. Also on Exynos PMU, on the GS101, these registers can't be written from Linux. So we've added support for like a syscon reg map, so you can write these registers. We've also queued just this week by Krzysztof, the CPU hot plug fixes, so you can offline and online the CPUs. This actually uses a kind of hint that needs to be programmed, so it's kind of a side channel to PSCI, so that'll be in 6.16. And at the moment we're working on CPU idle, so that's working. It's kind of a evolution of the hot plug patches a bit, and then that will enable CPU idle states. And it's worth noting that that replaces a lot of downstream code with very minimal kind of upstream code. Another area we did quite a bit of work on is Exynos UFS and the UFS PHY driver. So as well as the GS101 enablement and the PHY tuning calibration, we enabled the Hibernate support, Gear 4, write booster feature. Eric Biggers at Google has landed the inline encryption support for the Exynos hardware, so it's called FMP. Also, we had some stability issues that turned out to be incorrect cache coherency setting, so they've been fixed. There was some bugs that we fixed there where clearly those code paths could never have worked with Hibernate, so that's all merged. And also things like loading and unloading the modules now works nicely. If the link doesn't come up the PHY reference counting doesn't get out of sync with the glue driver anymore and things like that. So just general driver cleanup and stability issues. We are waiting on one. So the Exynos controller seems to be one of the only controllers that needs like Hibernate hooks. And we proposed a new API to the PHY subsystem to do these register writes, but we're still waiting for that. So Hibernate works, but it's not completely matching all the register writes that downstream does on the PHY. And I'll hand over to Tudor for APM.
Yeah. Hello. Yeah, so APM is a module built around Cortex-M, and its main goal is to offload the main CPU, the overall power management activities. The application processor communicates with the APM module via transport protocol called ACPM, and this transport protocol constructs the messages that are interpreted by the firmware that runs on the Cortex-M. So you can construct messages for and control PMIC, DVFS, thermal, CPU and cluster power management, and system cache management. We upstreamed the ACPM protocol core infrastructure that enqueues, dequeues, handles the messages, and also the PMIC transport PMIC message construct helper driver. Currently working in progress is the DVFS support and some firmware logging feature. The transport layer for this protocol is Mailbox. It's done via the Mailbox framework. GS 101 has few Mailbox instances, and their main feature is that they define a shared register area where the messages are written to, so that they will be passed to the firmware. And they also have an interrupt register where you can specify for which channel the message is for. In the ACPM case, the shared register is ignored, and instead they are using transmit and received queues that are defined into static RAM, and they use the Mailbox controller just to notify, just to ring the doorbell and let the firmware know that something has been written at that specific address into SRAM. Which brings me to maybe an improvement for the Mailbox core framework. All that the protocol similar to ACPM that they handle their own hardware queues need is just to flip a bit and let the firmware know that something is ready for a specific channel. So ideally, Mailbox core should provide, I guess it would be a good idea to provide a method so that the clients, the Mailbox clients, to call directly into the controller driver. Right now there's some complexity that's not needed. There's a software queue into Mailbox core that acts as a backlog when there are multiple requests. Just one is active and the rest are put in backlog. And when you receive a message from the firmware, you have to kick again the Mailbox core, which is not needed. And that's all from me. Andre?
Okay, hi. So for USB, GS101 uses a DWC USB 3.1 Gen 2 USB controller, which can act as a DRD device, which means it supports both host and device mode. And accordingly, there's a Type-C, single Type-C connector on the Pixel itself. This is complemented by a maximum 77759 PMIC, which includes USB Type-C controller, power delivery, and moisture detection, and a few other bits that are not relevant here. So we enabled this upstream, which included, so the main enablement was the corresponding PHY. It's quite an evolution of the previous PHY. So we enabled this upstream. On top of that, we added support to the PHY driver to subscribe to the roll switch USB notification framework. This is needed for two reasons. The PHY itself cannot detect cable disconnection status. And also it needs to know the orientation of the USB cable so that it can support SuperSpeed and SuperSpeed Plus, because of we need to configure the lanes in use. And then accordingly the PHY can notify the core of the current status, and the core can go into runtime suspend. We have I believe, clean upstream solution for this, whereas in downstream there was a big state machine to handle all this separate from the whole DWC core. And there were random calls from the DWC driver into the Exynos PHY. What else? So I mentioned one PMIC. There are in fact 3 PMICs on Pixel. The 2 other ones are Samsung S2 MPG 10 and 11. Initial support was queued for them as well. So we have an MFD core driver, we have RTC driver updates, we have a clock driver update. And these use the previously mentioned SPDY interface. On Pixel though, the SPDY is hidden via the ACPM. So on Pixel we use the ACPM as a transport. And currently missing are regulators and thermal sensors and GPIO, or in progress. And the S2 MPG11 is also not yet. Well, it started now, but it's not submitted yet. The third PMIC is then the Maxim 77759. So in addition to the USB parts, it also has a non-volatile storage, fuel gauge, GPIO expander, and so on. Initial support was queued there as well. Of note is the NVMem, because now this allows us to do a cold reset, because the NVMem is used to communicate with the bootloader what to do. And we have a third-party submission for the fuel gauge part, which is quite cool. Yes.
Okay, so this is kind of the roadmap for the next couple of releases. So 6.16, I mentioned the hot plug stuff. Andres mentioned about the PMIC. So that stuff's all queued. For 6.17, we're looking at enabling CPU idle, the regulators on the PMIC, because we need that for display. IOMMU we also need for graphics.
Custom IOMMU?
It is a Samsung.
Yeah, it's Exynos.
It's an Exynos. There is an upstream driver, but I think it supports like V6 to the IP, and we're V8 or something like that.
But it's not SMMU. No, it's the Exynos one.
CPU Freak, we want to get in, and some Exynos MCT driver updates that are required for CPU idle. And then I've put Arch Exynos there. So at the moment, when you enable Arch Exynos, it selects a bunch of drivers in the kernel. And for GKI, we don't want that. We want that just to... so the core kernel doesn't have hardware-specific drivers in it. Though timer and pin control and things will just get enabled as modules. So we're hoping to get those changes into 6.17. And then that allows us to switch over to some of the upstream drivers, which would be nice. Then following on from that, 6.18, we're looking at PCI Express and PHY, suspend to RAM, GenPD, and also automatic clock gating, ACG.
How's the automatic clock gating going to work?
This is a good question. So currently, we register all the gates and they're put in manual mode. So we may just we may continue to register all the gates, but set them in automatic mode, and then just make the enables and disables no ops, essentially. I mean, I think there's one SoC upstream that is taking the approach of, or one Exynos SoC that's taking the approach of just not registering any of the gates, and you rely on the bootloader to do it. But I know of at least one instance for the core site where you then, like, the automatic mode doesn't work quite reliably, so there's like, you have to kind of like hack it on, basically, you know.
You can do it per clock, this mode?
Yes. So it's actually based on an ARM Amber spec. And it's like a handshaking between the IP and the clock unit. And the IP sort of says, oh, I'm going to be active, and then just give me a clock, basically. Okay, so that's the roadmap for the rest of this year. CI obstacles. Over to you.
Yeah, and we can stay here. Short slides. So where the help could be useful. So there are folks in community who work on the Samsung, and of course they don't have the data sheets, and this is the main obstacle for them. So this would be great if some data sheets became public or half public for the SoCs from 8 years ago, for example, right? This is their obstacle. Another problem is limited CI. So I have my own board farm. I set it up long time ago, and I have there only ARM v7 boards. I got one Exynos 850. So this was from Samsung 2 years ago. I got it. However, it shares the network with the serial. Therefore, it does not fit exactly my setup because I use the NFS route. And because it doesn't fit exactly my setup, I need to rework it. And I'm in the process of reworking it since 2 years because not enough of time. But I would really like to have the ARM64 in my CI because I do test every commit. So every commit in my tree, I mean, yeah. And this is how my system works. It's on the wall now. I use the IKEA SCADIs. I don't have all the boards here. I have a few more, but they are in the drawer. These are the most important. The Exynos 850 is also there, but it's not plugged to the CI. The problem is that also kernel CI does not have 850 or other 64-bit processor. So the CI in the kernel is using the ARM v7. So it's really, really obsolete. And hopefully here as well, Google to the rescue.
Okay, so this is the goal that we've been trying to do, and this is many teams in Linaro working on this. So we want a reliable way to control form factor phones in CI, and there's other presentations that Connect about the Lava automation appliance. So we've been using that with this kind of 3D printed phone jig to enable some CI on Pixel hardware. So there's going to be a demo on Friday about it, but you can also see this running in the hacking room. Thanks to Ben and Terry, who've got that going. And it's also running its first jobs in LKFT. So these are all jobs that have been sent from the cloud to that device in the hacking room since we've been at Connect. So that's quite cool. And hopefully then we'll be able to improve the CI for Exynos on ARM64. And I'm sure we could 3D print you some kind of thing for your IKEA board. You could hang a phone up there. So that's some references. So the last link is like a README from the landing team on how to do all upstream kernel development on Pixel 6. So browse those references at your leisure. And that's it. Thank you very much. Any questions?
So about the Exynos 5 machines, I think this is one of the SoC platforms that has up to 4 gigabytes of RAM. In the Chromebooks, how sad are you going to be if we drop high mem for those?
Off. Working. Yeah. So I think all the Chromebooks have 2 gigabytes of RAM. I think
Okay.
there were no design with. But anyway, all the Chromebooks with the Upstream support, these are designs from 10 years ago, so or even more than 10 years ago. So if there's any user using these Chromebooks, I'm sure that battery is already dead. So I don't think it's a real
Okay, so
problem.
you're not aware of anybody reusing those Chromebooks for anything that they still do?
I think no.
Okay.
And the only use case I could imagine are the hard kernel or Droid boards, which are kind of small factor development. You can set up some compute platforms, things like that, but they have, I think, also 1 gig or 2 gigabytes of RAM, so also no problem.
Well, 2 gigabyte is a bit of a problem, but not a huge.
Yeah,
Okay.
correct.
So this is just a quick question. You want an E850 in kernel CI?
Oh yeah.
Okay, because we've got E850s in LKFT. We can probably make those available to kernel CI as well. It just comes down to hardware, as well as kind of our own testing, kernel testing schedules. So I think we can probably make that happen for you.
Great.
I have one more. Are you aware of any other SoCs that are not from Samsung or the other 3 or 4 companies that have made Exynos chips?
I'm aware of only one. The company is Axis, and
I thought there was a 3. Didn't you merge that?
no, I didn't mention. So there's a Tesla FSD, and there's an Axis company, and SoC's name ArtPeg. So the ArtPeg 8, because earlier designs are not Samsung based. And folks were active some years ago, but they also hit some obstacles that they were reinventing the drivers, and they never came back. So probably, yeah, they saw how much they have to do to bring the upstream, right? So yeah, but I'm not aware of any other such shared collaborations, shared designs. Great, it looks like that. So thank you very much for coming. Yeah. Thank you.